Hi, Mrs. Jacobs here, physics teacher at Naperville North, here to do a tutorial about how to draw an interaction diagram. The first thing I want to talk about is, what is an interaction diagram? It is a big picture look at all the objects in the situation and the force interactions between all of them. So we're not looking at just one object, we're looking at every object that's in that picture. The first step is to write out each object in the picture as words and boxes. And I will include the earth as a separate box, even though the earth, like the center of the earth, is not in the picture. Now, there are some teachers that combine the earth and the floor or the earth and the ground as one object, and you can do that. But the way I'm going to model it is that the floor and the earth are separate from each other. Okay? So before we go on to the other steps, I want to model what step one looks like. So here's my first practice problem. A box sits at rest on top of a table. So I have a table and a box, and I have the floor. Okay, and everything is at rest. In my interaction diagram, I have three objects: box, the table, the floor. It doesn't matter where you put them, in what order. You can have them in different spots than I do, that's fine. And then again, I put the earth as a separate box. Okay, that's step one. You write out all the objects. Step two, start with the force of gravity. It is the only non-contact force, and is the only force between the earth and all other objects. So I'm going to draw a line. So when I say start with the force of gravity, I mean you're going to draw a line between the earth and each object. So the earth and the floor, and we're going to label that as FG. Okay, that line cannot be an arrow because it's not a one-way force. It's a two. It happens on both objects at the same time. The earth pulls on the floor pulls on the earth with gravity. There's also gravity between the earth and the table. And there's also force of gravity between the box and the earth. Box pulls on the earth pulls on the box. Okay. Now that I've done the gravitational force between the earth and the other objects, I can't use gravitational force again. Okay. There is a force of gravity between all objects that have mass, but the force of gravity between the box and the table is insignificant. Okay. It's between the earth and the box and the earth and the table that matters. So step three is the last step, but it's the hardest step. You have to ask yourself, what is touching? If two objects are touching, there will be at least one force between them. There could be two forces between them. We'll see situations like that. There are only 4 options for your contact forces. Okay. The 4 contact forces that we are using are friction, tension, applied, and normal. And if you're not sure what those are, go back and look at the previous tutorial video about types of forces. Okay. So I'm going to start with the box and the table. The box is touching the table, so there will be a force between them. I'm going to draw one line to start with. Okay. That force is a supporting force. The table supports the box up, and the box pushes down on the table. That's called the normal force. So I'm going to label that Fn. The box is not touching the floor, so there will be no force between the box and the floor. The table, though, is touching the floor. So I'm going to draw a line around. Could go the other way, doesn't really matter, as long as I connect the table and the floor. And that's also a supporting force. The floor is supporting the table, and the table is pushing down on the floor. We also call that a normal force, Fn. That's it. There's no friction in this case because nothing's moving and nothing's like trying to move yet staying in place. Okay, everything is just at rest. There's just gravity and normal forces. Here in the next tutorial video, I'm going to go over how to draw the free body diagram for the box and the free body diagram for the table. So this tutorial is just about the interaction diagrams. Let's do another problem. A box is being pushed to the right across a floor by hand. The box is moving at a constant velocity. Here's my floor. Here's my box. Here's the person's hand that's pushing it, and it's pushing it to the right at a constant velocity. Okay. For my interaction diagram, I need a box. I need a floor. I need a hand, or you could put a person. I'm just going to put the hand and the earth. That's step one. I got my objects. By the way, there can be 5 objects, there can be 3 objects, there can be 6 objects. The first 2 examples have 4, but that's not a must for every problem. I'm going to start off with FG between the earth and all 3 objects. Then I ask myself, what is touching what? The box is touching the floor. So there has to be a force between them. And the floor is supporting the box up and the box is pushing down on the floor. We're going to call that a normal force. Okay. But this is a case where it doesn't say that the surface is frictionless. Okay. If it doesn't say that, you need to assume there is friction. So there's also a frictional force between the box and the floor. There are 2 forces. The last force is the hand is touching the box, and I'm going to call that an applied force, but you can use FAP or FA. Okay, that's going to be any sort of pushing force. Okay, later on in the next tutorial video, we'll do the free body diagram for the box. Okay, one more. A ball is rolling to the right across the grass and slowing down. Okay, this constant velocity and speeding up and slowing down stuff is going to become really important when we draw free body diagrams. It doesn't really affect the interaction diagram though. We have a ball, we have the grass, you could write the ground if you want, and we have the earth. There's no other object. There's no hand, there's no foot, there's no person hitting this or pushing this. I start with FG. Between the earth and all objects. And now once I've done FG, I can't do it again. So I ask, the ball is touching the grass. First of all, the grass is supporting the ball upward. Okay, and the ball is pushing down on the grass. Okay, that's a normal force. But once again, they don't say frictionless. Okay, so we're going to assume that there's friction since it's moving. It is kinetic friction, so you could put FFK or you can just put FF. That's fine. Okay. A good thing to note is whenever there's friction between an object moving across the surface, there will always be a normal force as well. There can't be friction without a normal force. It's that supporting that causes the rubbing interaction. In the next tutorial video, we will draw the free body diagram for the ball. Okay, hopefully this was helpful to give you a couple examples of interaction diagrams.